Um, what would be one piece of career advice that you could give, yourself or junior or sophomore in college?
I think, the advice I would give is to focus on being effective more than just being, knowledgeable or the most talented person in your team. And what I mean by being effective is, um, helping your team win and not just being the best player on the team. And, some of the things that I've learned over the years is, you know, to be effective and get things done. I've seen people that are very talented, very intelligent. They don't accomplish a whole lot because I don't think they focus on how they interact with other people and communicate. And I think, the way you can do that is to look around at the people you work with and help them be successful, give credit to other people, learn from other people, and be in a culture where it's okay to admit that you don't know things. I've been in some other organizations where there was a lot of pride and people, it wasn't okay to admit that you didn't know something. So just ask a lot of questions and, make sure the people around you are successful and you're contributing to everybody's success.
Good. Thank you for that. Well, I will let you take over and you can start presenting the information with regards to kind of our Aggregate 101 and best practices that Materials does.
Okay. Let's go ahead and get started on Aggregates 101. The way we like to look at the aggregates business is a part of what we consider a value chain. And it's a system of a bunch of different processes that are dependent on one another. So it's important to understand how each one of these processes interact with each other. And what we're trying to do is optimize the entire process. Starting, with aggregates, we have to strip off the soil and the weathered rock that's not quality that we can sell to our customers. Once we've done that, we're going to drill and blast the ore body, the good material that we want to process. Once it's been blasted, we have to load and haul it to the processing plant. And then at the processing plant, we're going to crush and screen and separate it into the different sizes that our customers want. The next step is to stockpile these products and load them into the customer's trucks. And then another process that doesn't directly happen at the quarry site is sales, but it's something that's very important to the entire process. But at the end of the day, we're trying to make quality products that satisfy our customers. Let's talk about a little bit of ag trivia. How many tons of crushed stone are produced annually in the U.S.? If you have a pen and a paper, I'm going to give you a couple of seconds and write down your answer, and let's just see how close you can get. So there's a little over 1.3 billion tons of crushed stone produced in the U.S. for construction purposes. All right, how many tons of aggregates are produced per citizen annually? About 4 tons per person every year gets used for roads, houses, sidewalks, all the things you can think of that aggregate gets used in. How many tons of aggregates are used per mile of 2-lane highway? About 25,000 tons. Or if you think about it, that's about 1,250 truckloads. So when you're driving around and you think about all the miles that you drive, think about, just how much aggregate we really use. So how many tons of aggregate are used to construct the average home? 300. So hopefully you got close on those, but that should hopefully give you a little perspective on how important aggregates are to our daily lives. All right, let's move into the aggregate deposits. That's where, really everything starts. We want to have good material that we can mine that we know will produce quality products that we're looking to make for our customers. The definition of a construction aggregate. It's a broad category of coarse to medium grain particulate material used in construction. And we call these sand, gravel, crushed stone, or recycled concrete. Those are the major categories. Aggregates are the most mined materials in the world. And there are different types of deposits or different geology that we use, but the three main categories are limestone, granite, and sand and gravel. So if you think about in the industry, we'll talk about quarries and we'll talk about sand and gravel deposits. So quarries are really just hard rock deposits that have to be blasted. Sand and gravel, or the technical word for that is alluvial, and these are areas where material has been deposited. And like I said, in quarries we have to blast it. In sand and gravel, we will excavate it, which we call dry mining, and that's with an excavator and trucks, or we'll dredge it, and we'll show you a dredge in a little while. But if you think about kind of this piece of pie over here, the different categories, limestone is the most predominant, 70%, granite's about 13%, and then we got some smaller types of deposits down here. All right, let's talk about sand and gravel. Again, they're alluvial deposits, and these are old riverbeds, floodplains, and coastal plain. And the main distinction, again, of sand and gravel is that these deposits generally do not need to be blasted, and we just can dig material straight out of the ground. It's more loose in nature. So the next categories for quarries are limestone, which is a calcium carbonate. It's hard for a sedimentary rock. It's the most common, as we saw before on the pie chart. It can also be mined for chemical properties, but that's not something that Summit does. Granite is another common type. It's an igneous rock. It's generally harder, often more structurally sound, and it's more abrasive. And that's a big thing for us in our industry. Granite is very hard on steel. It wears through a lot of steel, so it's a higher cost material to produce. All right, let's take a look at kind of where we might find some of these different types of deposits in the United States. This might be a little bit tough to read, but as you can see, limestone are the pink areas, very heavy in the Midwest, Texas, Florida, a little bit out in the West. Granite, you can see in the mountainous zones, very predominant in the Appalachian Mountains in the Northeast and some out in the West. And then trap rock, there aren't a lot of trap rock mines. They're very expensive to produce. And, there just aren't a lot of big cities in the trap rock areas, but there is some of that type of that mining. And then the other big one is sand and gravel, and it's the yellow areas. So as you might expect, we see the yellow sand and gravel along the rivers and then around the mountains where material has been deposited through erosion. All right, so how do we find these deposits? Through a process that we call exploration. One type of drill is what we call air rotary. This is, it doesn't give us a lot of detail about what's in the ground. It basically just gives us depths. So a lot of times we'll use this cheaper drilling method to just go through the soil and the weathered rock to find the top of the hard rock that we're looking for. The next most common is core drilling. This is a different type where there's a tube with a diamond bit on the head of it, and it will drill down into the ground and pull out these 2-inch columns that are placed in boxes, and we can really study what's down in the ground. It's a much more expensive way to drill and explore. Another type for softer ground is auger drilling. Again, it doesn't really give you a lot of detail on what's in the ground. It's mainly just there to tell you the depths of the different types of material. Another kind of interesting type of drilling is sonic drilling. This is for sand and gravel deposits that is loose, but what this does is it has an ultrasonic vibration that allows this tube to be pushed down in the ground, and then the material in the ground is pulled back up intact, so we can get a lot more detail about what's in the ground, and it doesn't mix the material together. Another type that's not real common but used sometimes is it's called geophysics resistivity. It's a process of placing electrodes in the ground and checking the electrical resistivity of the different types of materials in the ground. It doesn't give us a lot of precision, but like I said earlier, the drilling is really expensive, and this is a way to check for any big anomalies that might have been missed in drilling, and then we might want to go back and put another hole based on what we find with this electrical resistivity. All right, so what's a typical site look like? We talked about the value chain and the process before. So you can see at this site, we got the stripping and mining over here on the left. The stripping material is disposed of over here in the overburden storage. Material is hauled and dumped into the primary crusher here. And then there's a series of conveyors that takes the product back over here to the processing plant. The products are made here and loaded out with trucks. At this particular site, we have a rail load out, and that material is loaded onto the rail cars here. Another thing to look for in quarries are ponds. We have ponds that collect water that we use to wash the stone, and we need ponds to collect the water that has fines in it that needs to settle out before we can reuse or discharge that water. So the next step are quarry operations. Here's just some different photos. Here's an excavator with a hammer attachment that we use to break larger pieces of rock. This is a real typical scene within a quarry. We've got loading and hauling going on here. We've got drilling up here that's drilling for this next shot, and that's where we will mine next, that block of material. We talked a little bit earlier about alluvial deposits and dredging operations. These are some photos of dredges. Probably, one of the most notable things about dredges is that it's very low cost. We can produce a lot of material without a lot of complication and a lot of money. So what a dredge does is it kind of agitates these banks, and then these big auger heads will rotate and loosen the material, and the material is pumped up through the dredge, and there's a long pipeline that delivers that slurried material back to the processing plant. Sorry, let me stop this for a second. We've got a little video here that kind of shows you how a dredge will work. All right. So now talking about quarries, like we talked about before, the first step is stripping. Some photos here. Really what we're doing, we're just taking off the overlying layers of geology between the ground surface and the ore body. The materials that are moved are the trees, the soil, and the rock. The next step, as we talked about, is drilling and blasting. So the holes are drilled in a set pattern based on the characteristics of the geology and then the desired fragmentation. Something that is not obvious is that it's extremely important that these holes are the right diameter, they're put in the right place, and they're drilled at the right angle. If you think about the amount of explosives in the size of stone that's being blasted, it's really small. This hole might be 5 inches in diameter, and the block of stone that it's blasting, might be 12 foot by 12 foot. So you think about a 5-inch column that's got to blast, a column of rock that's the size of your bedroom, that's 50 feet tall. If we don't get that explosive in the right place, we're going to get a lot of boulders and things that we don't want, that we can't send to the processing plant. So each one of these holes are hopefully put in the right place, and then explosives are put into those, and we'll get nice fragmentation. We'll talk about this a little bit more in the next coming slides. So again, like I talked about, each one of these holes needs to be in the right place. And this is a picture of a typical drill. All right, so within the blasting process, some of the equipment that's used are what we call a blasting cap and a line. And there's delays between each one of those holes. If we go back up a couple of slides, not all of these holes detonate at the same time. They all go off individually. And this allows for some movement and proper breakage of the stone. And if we were to set off all these holes at one time, we would have some upset neighbors. So the way this works, there's a first initiation with this cap. The cap sets off this booster, and then that booster is going to detonate the bulk explosive that's poured into the hole. So the primary explosive, the material that I talked about that gets poured into the hole, is a fuel and an oxidizer. Most commonly, it's ammonium nitrate and fuel oil. And as I talked about, it's important to have the holes in the right place. There's a couple of different pattern types we'll talk about here. One is a square pattern, and one is a staggered or a chevron pattern. Sorry, and I'll stop this for a second. Here's some more videos to kind of give you a sense of what a blast might look like. Got a couple more here. Okay, so now we've got some blasted material. Now we've got to load and haul it to the processing plant. So two of the main types of loaders that we use, the first one is a hydraulic excavator. We use this in development areas. You can see in this photo, it's an area that looks like we're moving into a new area. It's used for tougher digging. You think about this little excavator bucket, it's really got a lot of force, and it's pretty small, so it can really pry out some tough material. So good digging force. It's got really fast cycle times, but it needs support equipment. You think about this machine on tracks and this small bucket, it's not going to do a very good job of cleaning up a large area in a short amount of time. So the more common that we use for main production is the wheel loader. As you can see, it's very mobile, very versatile, provides a lot of efficiency, so it gives us lowest cost for the bulk of the material that we want to move, and it's very long lasting. So if you think about this thing on wheels, it can move around very quickly. It's got this big bucket. It can clean up some materials, and it's very productive. So next, we're going to talk about the hauling equipment. Two main types of hauling equipment: rigid frame trucks and articulated trucks. This is a rigid frame truck, very common for most production. Low cost, high capacity, very durable. The next type is articulated, which is more versatile, and it's used for development areas. And if you think about this thing, the bed is separate from the cab, and it articulates, and then it's got more wheels, and really this allows us to drive in muddier areas where we're moving through material quickly and we're not building permanent roads. So they're higher cost, but they really provide us a lot more flexibility in the right conditions. So if the material is small enough, we're going to move it with conveyors versus a truck. It's very low cost for transport. It operates continuously. We avoid traffic issues, but again, it requires a smaller size, so this occurs after we blasted the material. Let's talk about haul roads for the trucks. A lot of times we might not make the roads wide enough, and trucks have to wait on each other to pass, but what we're looking for is 2 times the width of the truck for each lane, which is going to be 4 times the width of the truck for the roads. We're looking for consistent grades with smooth turns. That's so that the trucks are not shifting gears a lot, which creates inefficiency. A lot of times you'll see along the roads there are berms, and this is a safety feature. It needs to be at least mid-axle of the largest vehicle that travels on the road. And then we want a hard compacted surface. If you think about a soft road, it's just going to slow the equipment down and burn a lot more fuel. So next, once we've hauled the material from the blast to the beginning of the processing plant, we're going to dump the trucks into a big dump box into the primary crusher. And we'll see a little video here. All right, so let's talk about the processing part of the process. This looks a little bit complicated, but this is a plant flow analysis, and we use this to study what's going to happen within the plant. It's essentially a series of crushing and screening to get the desired sizes of stone that we're looking for. Some of the terminology we should go through, the different stages of the process are primary, secondary, and tertiary. Essentially, it's just a fancy word of saying first, second, and third. Some of the products that we make are base products, coarse aggregate, fine aggregate, screenings, and sand. Different crushing types that you'll hear in the industry: gyratory, jaw, cone, HSI, and VSI. And I've got some pictures of those coming up, so they'll make more sense in a minute. And then different screen types: incline, horizontal, and then just some of the other words that you'll hear used when we talk about the plant flow analysis or bottlenecks. And essentially what that means, each one of these pieces of equipment, or we call them units, it has a maximum capacity. And if you think about the material flowing through the plant, one of these units is going to be at its capacity faster than the other units. And we can't overload one piece or we'll have problems. So what we try to do is find reasonable ways to increase the capacity of one of these units so that it will allow more throughput through the entire process. And that's what we mean by bottleneck. You'll hear talk about product yields. That's just the percentage of this stream of product versus the total stream. So within this plant, we got 100 tons per hour of waste. We got 500 total tons coming in. So that's going to be a 20% yield of waste in this plant. All right, you saw earlier where we dumped the truck into a box. And once that material comes out of the box, it goes across a grizzly screen. And that's these bars here that we call grizzlies, and allows the finer material to drop down and bypass the crusher. And the purpose of that is if product is already crushed down to the size that we're looking for, there's no need to send it through the crusher. All right, we talked about earlier the different types of crushers. We've got a gyratory, jaw, and cone, and a horizontal shaft impactor. Here's some pictures, but I got some better pictures on the next slides. So the first stage of crushing, primary. It prepares the material for transport. It's smaller and easier to handle. Again, here are the 3 types we talked about. And Here's an internal look at the two different types of crusher that we use primarily. Here's an impact crusher. It's a big rotor here with bars on it, and this thing spins at a very high rate, and it throws the rock into these aprons up here, and it shatters the rock, and then it comes back down through here. Another common type is jaw crushers, where the larger material comes in here. This side of the jaw crusher rotates up and down, and it slowly just crushes the material down into smaller sizes, and it falls out the bottom. Gyratory crushers. These are, really large crushers. I think we only have one of these within Summit. So not real common, but for larger mines, use them for hard or soft rock, abrasive or non-abrasive. So very versatile, very large crushers. All right, let's get back to jaw crushers. We have what we call an overhead eccentric shaft. This big flywheel rotates, and it causes this one side of the jaw to rotate up and down, and it just pulls the rock in and it crushes it down. Again, it's easily identifiable by the big flywheels. So the next or secondary and tertiary stages, the more common crushers are cone crushers, and I'll show you what one of these looks like on the inside in a moment. And then we've got the horizontal shaft impactors. They're a lot like the ones we just looked at for the primary crushing, but they're just smaller. So here's a video of the inside of a crusher, a horizontal shaft impact crusher. And I think this video was taken back in the 50s. It's old. So that kind of gives you an idea of what happens inside these crushers. We talked about before the cone crushers. A different type of crushing happens here. The material flows down into the top, and then this mantle looks like a big bell. It's attached to the shaft, and this shaft spins, but it kind of oscillates. So this thing oscillates around in a circle, and the material is just slowly pulled and crushed as it falls down through the chamber. Another type is a vertical shaft impact crusher. Material is fed in from the top, and then it's kind of flung. It hits this table, which is spinning, and it throws the rock to the outside, and that's the force that causes the material to shatter, and then it falls out to the bottom. So, secondary and tertiary crushing. Again, just some different views of internals of cone crushers. Another part of the process is screening. This is a typical screen. What we call these are decks. There's 4 decks here. The size of these screen holes are going to be reduced as we go down, and we're just going to make different size products as the screen shakes and separates the material. Something that's very important to us is keep the right bed depth. If this material gets too thick, then pieces that we want to fall through the screen don't have an opportunity to find their way down through that thickness of material, and we'll get that material carrying over and getting into products that we don't want.